Welcome to the fascinating world of quantum physics. This field of science might sound intimidating, but it's really about the amazing things happening at the tiniest levels of existence. We're talking about atoms and the particles within them. What makes quantum physics so special? It reveals a reality completely different from our everyday experiences. In the quantum world, particles can be in multiple places at once. They can act like waves and particles at the same time. This isn't just theoretical mumbo-jumbo. Quantum physics affects our lives in profound ways, from the technology we use to the very nature of reality itself. So buckle up. Get ready for a mind-bending journey. Imagine a world much smaller than a grain of sand. This is the realm of quantum physics, where we meet a cast of curious characters: atoms, electrons, photons, and quarks. These particles, the building blocks of everything, don't behave like the objects we see in our daily lives. They zip around, not in predictable paths, but in blurs of probability. They can be in multiple states at once. It's a world where intuition goes out the window, and the rules of the game are entirely different. But these tiny particles have a big impact. They hold the key to understanding how our world works at the most fundamental level. One of the most mind-boggling concepts in quantum physics is wave-particle duality. Imagine a beam of light. Sometimes it behaves like a wave, rippling outwards like waves on a pond. This is how light diffracts through a prism, creating a rainbow of colors. But light can also act like a stream of particles called photons. Think of the photoelectric effect, where light knocks electrons off a metal surface, just like tiny billiard balls. The mind-blowing part? Light isn't switching between these two states. It exists as both a wave and a particle simultaneously. The same goes for all other quantum particles, blurring the lines of what we thought we knew about matter. Hold on to your hats, because we're diving into superposition. Imagine a coin spinning in the air, not yet landed. It's not heads and it's not tails. It's in a superposition of both states. Quantum particles do something similar. Until we measure them, they exist in a haze of possibilities. They could be here, there, or everywhere all at once. It's like a video game character that exists in multiple locations until you choose one to display on the screen. This concept challenges our classical understanding of reality, where things have definite positions and properties. Section 5. The double-slit experiment, a peek into the quantum world. The double-slit experiment is one of the most famous experiments in quantum physics, and for good reason. It has puzzled and fascinated scientists for over a century. It demonstrates the strangeness of the quantum world like no other. This experiment challenges our understanding of reality and forces us to rethink how we perceive the universe. Imagine shining a light at a barrier with two slits. This setup might seem simple, but the results are anything but. Behind the barrier is a screen. This screen is crucial as it captures the behavior of the light after it passes through the slits. You might expect to see two bright lines on the screen where the light passed through the slits, right? This is what classical physics would predict. But here's the kicker. Instead of two lines, we see an interference pattern, like waves overlapping. This pattern is a series of bright and dark bands indicating that the light behaves like a wave. This pattern emerges even when we shoot single photons, one at a time. This means that each photon is not just a particle, but also exhibits wave-like properties. It suggests that each photon somehow travels through both slits simultaneously, interfering with itself. This phenomenon is known as wave-particle duality, a cornerstone of quantum mechanics. The double-slit experiment has profound implications. It suggests that particles can exist in multiple states at once, a concept known as superposition. This challenges our classical understanding of particles and waves. Understanding this experiment is crucial for the development of quantum technologies such as quantum computers, which promise to revolutionize computing by leveraging these strange quantum properties. The double-slit experiment is a gateway to the quantum world, revealing the mysterious and fascinating nature of reality at the smallest scales. It continues to inspire and challenge scientists, pushing the boundaries of what we know about the universe. Section 6. Schrödinger's cat, a thought experiment. Get ready for a thought experiment. This one is a classic in the world of quantum mechanics and has puzzled and intrigued scientists and philosophers alike for decades. Imagine a cat inside a box. But this isn't just any ordinary box. It's a sealed, opaque box that you cannot see into or interact with in any way. Along with the cat, there's a tiny bit of radioactive material, a detector, and a flask of poison. These elements are crucial to the experiment and set the stage for the quantum conundrum. It's a setup designed to be potentially lethal to the cat. The radioactive material is unstable and could decay at any moment, triggering a chain reaction. Now here's the twist. The radioactive material has a 50% chance of decaying within an hour. This probability is what makes the experiment so fascinating and perplexing. If it does decay, the detector triggers the poison, and the cat tragically meets its end. This outcome is one of the two possible scenarios. If the radioactive material does not decay, the cat is safe and sound. This is the other possible scenario where the cat remains unharmed. Until we open the box, the cat exists in a superposition of being both alive and dead. This means that, in the realm of quantum mechanics, the cat is simultaneously in both states. This thought experiment helps us visualize the concept of superposition. But more importantly, it highlights the bizarre nature of quantum measurement. It challenges our understanding of reality and forces us to reconsider how we perceive the world at the smallest scales. Schrödinger's cat is more than just a quirky idea. It's a profound illustration of the complexities and mysteries of quantum physics. It continues to inspire and provoke thought, reminding us that the universe is far stranger than we can imagine. Section 7. Quantum tunneling. Through the looking glass. Have you ever wished you could walk through walls? Well, in the quantum world, particles do it all the time. This is called quantum tunneling. Imagine a particle approaching a barrier, like a ball rolling up a hill. In the classical world, if the ball doesn't have enough energy, it rolls back down. But in the quantum world, there's a chance the particle can tunnel right through the barrier. It's as if the ball suddenly appeared on the other side of the hill. This bizarre phenomenon is essential for many technologies, including transistors, the building blocks of our beloved computers. Section 8. Quantum entanglement. Spooky action at a distance. Prepare for the spookiest phenomenon in quantum physics, entanglement. Imagine two particles linked in a special way. No matter how far apart they are, even on opposite sides of the universe, measuring the state of one instantly determines the state of the other. It's as if they're communicating faster than the speed of light. Einstein famously called this spooky action at a distance. Entanglement has profound implications for our understanding of reality and is a key resource for quantum computing and communication. Section 9. Quantum physics in action. From lasers to smartphones. Quantum physics is not just a theoretical curiosity, it's the foundation of countless technologies we use every day. Take lasers, for example. Lasers are a direct application of quantum mechanics, harnessing the principles of stimulated emission to produce coherent light. This coherent light is what makes lasers so powerful and precise. They rely on the quantum properties of light to produce highly focused beams used in everything from barcode scanners to laser surgery. Barcode scanners use lasers to read the information encoded in barcodes, making shopping and inventory management more efficient. In the medical field, laser surgery allows for minimally invasive procedures, reducing recovery times and improving patient outcomes. Our smartphones and computers wouldn't exist without transistors, which exploit quantum tunneling to control the flow of electricity. Transistors are the building blocks of modern electronic devices, enabling the miniaturization and performance improvements that have revolutionized technology. The ability to control electrical currents at the quantum level has led to the development of faster, smaller, and more efficient devices. And let's not forget medical imaging techniques like MRI, which use the magnetic properties of atomic nuclei to create detailed images of our insides. MRI machines rely on the principles of nuclear magnetic resonance, a quantum phenomenon, to visualize the internal structures of the body with remarkable clarity. This technology has become indispensable in diagnosing and monitoring a wide range of medical conditions. Quantum physics is even paving the way for quantum computers, which have the potential to revolutionize fields like medicine and materials science. Quantum computers leverage the principles of superposition and entanglement to perform complex calculations at unprecedented speeds. This could lead to breakthroughs in drug discovery, optimization problems, and the development of new materials with unique properties. The future of technology is deeply intertwined with the advancements in quantum physics, promising a new era of innovation and discovery. Section 10. Conclusion: the quantum future. So, there you have it, a glimpse into the strange and wonderful world of quantum physics. We've explored mind-bending concepts like wave-particle duality, superposition, and entanglement, and seen how these principles underpin our technological world. But this is just the beginning. As we delve deeper into the quantum realm, who knows what other mysteries and wonders await? One thing's for sure, the future of science and technology will be inextricably linked to our understanding of the quantum world.